Alright, 2.5, the polynomial remainder theorem. Objective. Students will be able to use the polynomial remainder theorem to determine the factors of polynomials and their remainders when divided by linear expressions. Okay, sounds like a lot of big words. Here's the remainder theorem, and it's pretty remarkable that it works. It's this. It's that the remainder, if you divide something, a function, by an expression like this, the remainder is the value of the function when you evaluate it at that factor. What does that mean? Okay. So here it is in mathematical terms, but here's an example. Let's say I was going to take this expression and divide it by x minus 1. Well, we can actually do that. We learned how to do that last chapter. We could do it long division. We could do it synthetic. I think synthetic's probably a little bit quicker, so let's do that real quick. Remember, I'm looking for the value that I would plug in here to make it 0. That'd be a positive 1. So I'm going to put a 1, put it in a little square. Put all my coefficients, which should be 3, negative 4, 7, and then draw my line down here, and this little box is my remainder. So whatever goes here, that's going to be my remainder. Alright, bring down the 3. 1 times 3 is 3, so I put a 3 here. Negative 4 and 3 add together make negative 1, so I put a negative 1 here. 1 times negative 1 is negative 1, so I put negative 1 here. 7 minus 1 is 6, so it is 6. It has a remainder of 6. Well, if I still look at this 1 here, and I think of, I got that 1, remember, because that's what divided this as 0. What would I get if I actually took this 1 and I plugged it into this function that I divided from? So that's the f of x that's on top. Notice we would put that function on top. Well, what would I get if I took that 1 and I plugged it in? In other words, see how it's x minus 1, or x minus a. What is the a value here? The a value is 1. And what happens when I plug that a in? Well, let's do it down below. And we're going to see it's pretty interesting what happens here. Let's do it in blue. So I'm saying I want to find out what f of 1 is. And so I say, well, that equals 3 times 1 squared minus 4 times 1 plus 7. Well, this is pretty easy to evaluate. 1 squared is just 1, times 3 is 3, 4 times 1 is 1, so that's minus 4 plus 7. Well, 3 minus 4 is negative 1. Negative 1 plus 7 is 6. And so we find out that the f of 1 equals our remainder. Sorry, I moved it a little bit here. But it equals our remainder. It's the same thing. So this makes it really easy. If a problem asks for us to find out what the remainder is, we don't actually have to divide. Down here, what is remainder r when the polynomial px is divided by x plus 1? We don't actually have to divide. We can just figure out what the a value is and plug it in. That makes it a lot easier. So let's go ahead and try it on this one. Think about what your a value would be. Remember, your a value is what you plug in here to make it equal 0, so it would be negative 1. So maybe it's a good idea to start off with, you just make a little note that a equals negative 1. So that means you're not really trying to divide, you're really just trying to find out what happens when you plug in a negative 1. This, again, much easier to do than actually dividing, because all you're doing is just plugging it in. Well, negative 1 cubed, that's going to stay negative, so that just becomes negative 1. Negative 1 squared becomes positive, so that becomes a positive 4. Then you have a negative 1. And a negative 6. So negative 1, positive 4, that's positive 3. 3 minus 1 is 2. 2 minus 6 is negative 4. And there we have it. We have the remainder is negative 4. Pretty straightforward, not super difficult. I think you guys can do it. Remember, if you ever get a situation where the remainder is 0, then that means that this thing goes into there perfectly. It's a factor of that. So this is a way that you can find factors pretty quickly. So I want you to try practice one on your own. Just give it a shot, see what you come up with, and then check back to see if you did it correct. So when you work this all out, you end up with, plugging a 2 in, you end up with 0. You get 80 minus 80. So it turns out that this expression x minus 2, because we got a equals 2 from there and plugged it in, we got a remainder of 0. Well, that means that this expression goes into this function perfectly. It's a factor. And so in fact, if you were to divide this out, you could find some of the other factors there. So pretty neat. We found one of the factors, and if we wanted to, we could go ahead and long division or use synthetic division and see what the other factor would be. Pretty cool. But that's it for this polynomial remainder theorem. We'll play with it more in class, and I'll see you guys in the next video.